Let's solve the secret handshake exercise on Exercism using Elixir language. Alright, first let's go and describe the task we have to do. So, in essence, this exercise is about translating a given binary code into a series of actions. So those series of actions are called a handshake. So, for example, we have a binary code 1010, and each bit in this code represents a specific action. And how, you might ask? Well, you have actions according to this table here. The least significant bit in the code corresponds to the action wink. The second bit in the code, starting from the least one, going from right to left, is double blink. And then the third one here is close your eyes, the fourth one is jump, and then the fifth one is actually a special bit for reversing the order of the actions in the code itself. Okay, so coming back to our example right here, we have 0 as the least significant bit, which means wink is not in the resulting handshake. On the second spot right there, which corresponds to double blink, we have 1, which means that double blink is in the resulting handshake. So we're gonna just write it here as an array, double blink, like this. And then the third spot, the third bit from the right is 0. This corresponds to close your eyes. So since it's 0, it's not there. Fourth one is 1, which is jumps, which is set to 1, so we're gonna include it here. Okay, so according to this code, the handshake is this. So what if we have the same code, right? But the fifth spot, fifth bit, is set to 1. What this means, according to the table above, is that this is a special bit for reversing the order of the actions. So basically, this bit reverses the order of these actions, which means that we have the same actions, it's just inverse. So we have jump and double blink. Okay, so hopefully now you know what this problem is about and how would you approach solving this exercise. So give it a try, and after that you can come back, take a look at the solution, or just continue on watching this video and we'll proceed with implementing this in the code. Okay, to start off, we're gonna just describe the algorithm we're gonna use for implementing this solution. The way we're gonna solve this is for a given code. For example, let's come back to that example 1010. We're gonna use the AND operation on that code to check whether a specific action exists inside. So for example, if we want to check if wink is in this code, right? So wink is least significant bit must be set to 1. So we're gonna just AND this code with 1. So the result here would be 0, which would mean that wink is not in the handshake. Alright, so if we wanted to check for double blink, then we would use the AND operation on the code with 10, which here would actually result in 10. And 10 binary is 2, but that doesn't even matter because we just want to check if the result is 0. So since this is not 0, that means that double blink is in the handshake. Alright? And so on. So we would proceed checking the code with all of the actions, and we would know which actions are in the code or not. And we would build up the array of resulting actions in the handshake as we go and check action by action. We would do the same for the special bit for reversing, and then if it's set to 1, we would in the end just reverse the array. And finally, now let's jump into the code and implement this. Let's use the test-driven approach and start with the test. We'll start by implementing the first test. So here we can see that there is a code 1 being passed into the commands function, and the test expects that this code or this function returns the array with the action wink inside, because one binary corresponds to wink. So let's run this here. We're gonna run the test suite. Alright, so now we see that the test fails as we expect because we haven't implemented it yet. So let's jump over to our code and let's make this pass. So for now, we're just gonna write the bare minimum code to make this test pass. So over here, we're gonna just call another function inside called Handshake, and we're gonna pass in the code. So now let's just implement this function. We're gonna make it private. And we're gonna use pattern matching to match the value we expect. And here we expect the binary 1. So we're gonna write 0b, that's used in Elixir for binary numbers, 1. And for binary 1, we're gonna return the expected array with the action wink. Okay, so if we save this and we go back to our tests, we run the test suite and we see that it passes. All right, so what are the next tests? We can see that the following 3 tests actually are quite similar to the first one, but they all are related to just supporting one action in the handshake. So double blink, close your eyes, jump. So now let's make our implementation more general, so it works with any code that has a single action in the handshake. So let's enable all of those 3 tests. Okay, we save it and then we make sure that these tests fail, which is exactly what happens here. All right, and let's go to the code. Let's make those 3 tests pass. So instead of just writing out all of these different codes and returning back the corresponding handshake, we're gonna make it a bit more nicer. So let's first define a constant in the module. We're gonna call it actions by number, or num. And we're gonna make this map. And in this map, we're gonna make the keys being equal to codes. And the values for those keys will be our expected actions. So binary 1 is wink, what we already have below. And then we proceed with writing out all of the remaining codes and their corresponding actions. So this is double blink. This is close your eyes. And finally, this one is jump. Okay, now we can make this function more general. So we can just write out code here. So for any code that is passed in here, what we want to do is return an array. And we're going to have a single action in this array as well, because that's what we're implementing right now. But to make it more general, we're going to just use the constant we have defined. So we're going to write out actions by num. And since this is a map, we're going to fetch the corresponding value using the key. And the key is code in this example. So in order to fetch the corresponding action, we are keying it by the code. Okay, so we are going to save this and go back to our test, open up the shell and run the test suite, and boom, this now is green. Okay, so let's proceed now. The next test, as you can see here, checks whether we can combine any of the 2 actions in the code. So 3 is binary 1, 1, which should return the handshake of the actions wink and double blink in that order. So let's enable this test. Let's save it and run the tests. Okay, this fails and now we should make it pass. Let's jump over to our code. And first what we want to do is go action by action right here and test whether that specific action is in the code that is given in as an argument here in the commands function. So in order to do this, let's go step by step. First, let's just fetch all of these codes that we are going to check, individual action codes. So for this, let's just store them into the action numbers variable. We're going to use the map.keys function to fetch the keys of the map. And we're going to pass in our map. The result of this keys function will be an array of all the codes right here, the binary codes, but the order of them is not guaranteed because map is not an ordered collection. So we have to sort it somehow. And we can actually sort it by using the enum.sort function. So to make this a bit prettier, we can just use this operator right here and write out enum.sort. So what this operator does is just takes whatever is on the left side, and that is the result of the keys function, and passes it in to the sort function on the right as an argument, as the first argument to this function, which is exactly what we want right now. And then the result of this sort function will be stored in action numbers, which is an ordered array of the codes that we want to test. Let's proceed. Now what we want to do is we want to call another function which we are going to implement soon. And we want to pass in the code consisting of all the actions. And then we want to pass in the action numbers, which we built out right now. And finally, we want to also pass in an empty array because we are going to use this array to build out our resulting array of the actions. Okay, so this function here, we really don't need it anymore. We're going to just remove it. And we're going to define a new getHandshake function. It's also a private function. And here we're going to catch the code that we passed in. As for the action numbers array, we're going to decompose it into the first element and the tail, or a head and a tail. So we're going to call it action number as the head, which is a single element in that array, and action numbers, which are the remaining elements of that array. This one is also an array. And finally, we have the handshake itself. That's also an array or a list. And initially it will be empty array, but as we recursively call this function, it's going to contain whatever we collected, whatever actions we collected so far. So what we want to do is actually check whether this current action code is in our input code. So we can use a guard to check this condition. And we do this by using the AND operator between the current action number and the code. And we have to check whether this is not equal to 0, in which case this means that the current action which we are checking is in the code. So then in that case, we want to keep recursively calling the same function. The code remains the same. Here we put in the action numbers. It's a tail of this list right here because the action number we have currently checked right here. So we want to proceed with the rest of them. And as for the resulting handshake list, we need to take this list and prepend the current action because we want to include it in the resulting list. Here we are going to write out which action. Well, we can use our translation table or a map right here. Actions by num. And we want to use the action number right here to fetch the action string keyed by the code. And then we can use the pipe operator to construct the list. And here we put the handshake as a tail of this list. So this is whatever list we have built out already. And now we have prepended the new action to that list. All right, so now we have covered the case when the action number is in the code, in which case we just append it or prepend it to the list. And now we need to write out another clause of the same function, which will be used in all the other cases. And those all other cases are when this action number is not in the code. So here we're gonna write out code. Here we're gonna write out the action number again. And the tail. And the handshake. Now we don't need the guard, because if this guard fails right here, the opposite is already implied. So we're gonna just write the body of the function. And in this case, we're gonna call recursively the same function again. The code remains unchanged in this case. Since the action number is not in the code, we're gonna just pass along the action numbers to continue processing the rest of them, and the handshake will remain the same because we don't want to include the action that corresponds to this action number because that action number is not in the code. And as you can see here, since we are actually not using this action number anywhere, we can prepend it with an underscore saying to the Elixir that it should ignore this variable. And now we're missing one more thing. And that is to actually write out function clause which terminates the recursive calls. So in that case, we can put it right here. This is the first thing we should check. In that case, we don't care about the code. The list with the action numbers will be empty, which means we have processed all of the action numbers and we are done. We have our resulting handshake, which we have built out through all the recursive calls. And as for the body of the function, right, we want to just return the handshake. Because by this time, it's going to contain all of the actions that are present in this code. But actually just returning it is not enough because we have been prepending the actions right here. So the order is inverse. So we need to use the enum.reverse function to just reverse the elements in this list. Forgot to put the E right here. Okay, so we have been going in order: wink, double blink, close your eyes, jump, but we have been prepending those actions to the handshake each time. So because we have been prepending them and not appending them to the end, they are going to be in the inverse order. That's why we are reversing them right here at the end of the recursion. Okay, we can save this now and we can go over to our tests, and let's jump over to the shell and run this thing. Okay, we have an error somewhere. It's on the line 31. Let's see what it is. Okay, so, okay, it's the AND operation. It's actually defined in the module called bitwise, so we forgot to import this module right here on the beginning of the module. So let's save it now and let's go back and run the tests again. And okay, now we get our tests passing. Okay, so let's look at what's next. Next up, we wanna enable the test, this one, which is actually reversing the two actions. So in this case, the most significant bit in this code right there is set to 1, because basically number 19 is corresponding to 10011 binary code. So as you can see, it's 1, 2, 3, 4, 5th bit right here is 1, which means that we need to reverse those two actions. Okay, so we can save it and make sure that this is failing, which it is. Okay, let's close this down and let's go back to our implementation. So right here, what we need to do actually is add a check whether the code, this code right here, contains the 5th bit set to 1, which would make this complete handshake reversed. Okay, So we can actually do this right here at the end when we run out of the codes to check. So here we can write def p get handshake, right? And then we have our code. We have our actions array, which we have exhausted because we have checked all of the regular actions, and the resulting handshake. And in this case, we actually want to use a guard. So we can say when this code right here is reversed. And we can do that using the similar kind of operation as right here. So we need to use the AND operation, and we can write out directly the binary code for reversal, and that is corresponding to this code. This is the 5th bit from the right, so that corresponds to this comment right here, as you can see. Alright, and then we can use the AND operation on that code, which is right here. And we want to check if this is not 0, because if it's not 0, then the reverse operation is in this code. Alright, so then we want to do, in this case, we want to just return the handshake. Since the handshake is already reverse, because we have been prepending actions to the resulting list, that's what we want to return. Previously, if the reversal operation is not in the code, we are reversing it. So right here, we don't need to reverse it. We save this now, and we go and run these tests again. Okay, now we have the test passing. And now, let's take a look at the other tests remaining. So here, reversing one action gives the same action, reversing no actions gives no actions. Then we have all possible actions right here, or reversing all possible actions. This is what we expect. Do nothing for 0 and do nothing if lower 5 bits are not set. So as it looks like here, I think we have already implemented all of these tests by the current implementations. So let's just enable those. Okay, right here. Let's enable all of them and save it, and let's run our test to check whether this is true. Okay, and as you can see, we have now made all of our tests pass, which means that we are done with this exercise. Alright guys, so I hope you guys tried solving this on your own before you checked my solution. And please let me know, how did you solve it? Was your approach the same? Was it different? Was it more elegant? Let me know in the comments down below. And of course, if you like this video, don't forget to subscribe to stay updated on the next ones to come. Thank you and see you next time.